In this video, we are going to talk about subsurface water on Mars shocks astronomers and defies expectations. So before starting this video, please like this video and subscribe to our channel for future updates. New seismic data analysis from NASA's Mars InSight mission has revealed a few significant surprises. The first surprise is that there is little to no ice in the upper 300 meters or 1,000 feet of the subsurface under the landing site near the Martian equator. Earth may become uninhabitable. Jardel Descent, another graduate student in the lab Right Directs, stated, "I've heard the Earth may become inhospitable my entire time growing up. I've reached the age when I can help create the knowledge about another planet that could lead us there." Proposed International Robotic Mars Ice Mapper mission. In order to find out if there is life on Mars, scientists want to go beneath the surface, since there is no liquid water on the surface. Radiation protection would apply to life below ground. The Mars Life Explorer mission idea will be a NASA priority for the following 10 years after a sample return mission. Drilling 2 meters or 6 feet into the Martian crust at high latitude is the plan in order to look for life where ice, rock, and the atmosphere converge. The proposed International Robotic Mars Ice Mapper mission is already being taken into consideration by NASA to assist in identifying potential scientific objectives for the first human missions to Mars. Young scientists are prepared to participate in such missions with the aid of Scripps oceanography. Applied rock physics computer modeling. A Marsquake's seismic waves can reveal information about the materials they travel through. Seismic velocities are impacted by potential cementing minerals as calcite, colonite, clay, and gypsum. The velocities acquired from the InSight data were interpreted using computer modeling of rock physics by Wright's team at Scripps Oceanography. To account for errors in our conclusions, we ran our models 10,000 times each, according to co-author Richard Kilburn, a graduate student in Wright's Scripps Technoruck Physics Lab. The findings are best fit by simulations that depict a subsurface made primarily of uncemented materials. InSight spacecraft landed. A flat, clean plain near the Martian equator called Elysium Planitia is where the InSight spacecraft made its 2018 landing. A seismometer that gauges earthquake and meteorite shocks was one of its instruments. This information can be linked to a vast body of surface-related data, such as temperature and photographs of Martian landforms. The surface data suggested that lava flows and sedimentary rock might make up the subsurface. The team still had to take into account unknowns regarding subsurface characteristics like porosity and mineral richness. Scientists suspected. Manga and other planetary scientists have long held the suspicion that the Martian subsurface would be covered in ice. Their misgivings have vanished. At the Martian poles, large ice sheets and frozen ground ice still exist. As scientists, we now have access to the best information and observations. And according to our predictions, the aquifers beneath the frozen Earth should still exist at that latitude, said Manga, professor and head of Earth and Planetary Science at UC Berkeley. Cement hold rocks. Minerals that do not serve as cement may also absorb water. However, Wright noted that the uncemented subsurface eliminates one method of keeping a record of life or biological activity. By virtue of their very nature, cements keep rocks and sediments together, preventing them from being eroded away destructively. In the 300 meters or 1,000 feet beneath InSight's landing site near the equator, there may not be enough water to support the presence of cemented sediments. The typical temperature in the equator of Mars is below freezing. Therefore, if water existed there, the temperature would be low enough for it to freeze. Second surprise. The second surprise defies a prevalent hypothesis of what transpired to Mars water. It is thought that the early past of the red planet may have included oceans of water. Many researchers hypothesized that a significant portion of that water ended up in the minerals that go into making subsurface cement. If water is exposed to rocks, it creates a new set of minerals, such as clay, and ceases to be a liquid. According to study co-author Michael Manga of the University of California, Berkeley, It is a component of the mineral structure. Though the rocks are not completely covered in cement, there is some of it. Analysis of geophysicist. We discover that Mars' crust is permeable and fragile. The sediments lack enough cementation. According to geophysicist Vashan Wright of the Scripps Institution of Oceanography at the University of California, San Diego, there is either no ice there or not much ice present in the pore spaces. On August 9, 2022, Geophysical Research Letters released an analysis by Wright and 3 other writers. The existence of ice grains, or tiny ice balls, that are not binding other minerals together is not ruled out by these observations, according to Wright. How likely is it that ice will exist in that form? Thanks for watching. If you enjoyed the video, subscribe to our channel and hit the like button. Don't forget to hit the bell icon for future updates. Until next time.